Hello, good morning friends. Today I am going to explain the non-stoichiometric defect in the solids. So let us try to understand what do we mean by non-stoichiometric defect. Non-stoichiometric defects means there will be the difference in the ratio of cation and anion. What is meaning of the difference in the ratio of cation and anion? That is Na plus is there, so it will not be equal to the Cl minus. So whatever the ratio we required 1:1, this ratio will not be maintained. Okay, but what other things we have to maintain, that is electrical neutrality we have to maintain. In this non-stoichiometric defect, number of electron loss equal to number of electron gain. This should we have to follow in this non-stoichiometric defect. Non-stoichiometric defect, it doesn't mean that there is the loss in the electrons and all. Electron will be the as it is. Only the cation or anion may be lost. So non-stoichiometric defects are two types are there. First one is the metal excess defect and second one is metal deficiency defect. What is metal excess defect? Metal excess defect means there is a more number of ion will be there in the crystal lattice, while metal deficiency defect means number of metal ion will be less. Now metal excess defects can be two way. First one is due to anionic vacancy, that is anion is missing, and due to extra cation at interstitial position. So if you see here, that is NaCl, if you see, I am taking the further due to anionic vacancy. If you see that is NaCl, so if you are hitting this NaCl, so what will it will give? It will give the Na plus half Cl2 plus electron. Now this Cl2 will be escape out. So what is left? Na plus and electron minus. Now there is the similar charges are there, one positive, one negative. So what will be having, that is one electron will be there in the at the position of the chloride ion, and rest of position as will be as it is will be NaCl minus, alternately Na plus and Cl minus. This this electron is surrounded by extra number of sodium atom, extra metal atom, and that is known as F center, and this impart that is yellow color to the solid, yellow color. Now if you see, that is for this you will find that is there are so many examples are there for this type of defect. If you go, that is the, if you take the example of the F center, so NaCl will give the yellow color, and similarly KCl will also give, KCl will give the, it will give the violet color. KCl will give the violet color, and while the LiCl is also there, LiCl when you go it will give the pink color. LiCl it will give the pink color. So this is the what the group 1 metal halides are there, they will give that is like KCl violet, NaCl yellow, and LiCl pink color. Why? Due to presence of F center. F center is nothing but the excess of electron in the lattice side. Now another example, when we are going due to the metal excess defect only due to extra cation at interstitial site. So due to extra cation at interstitial site means what? That is, if you see, that is the ZNO is there, ZNO. So if you are hitting ZNO, it will give that is Zn2 plus 1 by 2 half O2 plus 2 electron. This O2 will be missing. This O2 will be missing. But in this case, what is happening? Zn2 plus and 2 electrons are there. Both will acquire the interstitial site, interstitial position. Both will go to interstitial position and impart color to the solid. So here you see that is Zn, alternate Zn2 plus O2 minus are there, and if you see the, this will also, because of presence of the electrons, it will also turn the yellow color, ZNO. If it is the ZNO and there is no loss of electron, there is no ionization, so it will be the colorless. But when this heating will takes place, So zinc will convert Zn2 plus, and O2 will released out and 2 electron will be there. So this will impart the yellow color to the crystals. So in this case, what is happening in the due to extra cation at interstitial position, there is the excess number of metal ion will be there. That is why metal excess defect. And what is happening there is the Zn2 plus ion and 2 electron also occupy the interstitial position. Now next one is the metal deficiency defect. What do we mean by metal deficiency defect? Metal deficiency defect means so many ions are there. Actually, they look like the 1:1, but they are actually found in the lesser amount of the cations are there. That is 0.95%, and oxygen is 100%. And that is what there is the number of metal ion itself is very less in this type of ion. And what to balance the charges, what we are adding? We are adding that is extra Fe3 plus higher charges cation to balance the number of the electron and positive charge. So this is all about the non-stoichiometric defect in the solids. Thank you so much for watching, friends.